Evening mga Bisaya. So our topic for today would be about foundation. So we have this one is strip and spread. This is under shallow, and then piles, of course, the deep foundation. So over like for almost 30 years, I came across different types of foundation. Now back home, the most common foundation is we have strip. So we have a strip, or the other term for strip footing is continuous. Continuous footing, and then spread, or we sometimes call it isolated footing. And then piles. I've seen piles cast in place and driven concrete piles. So this one, I have here a screenshot of all types of foundation that I did, um, except some few. Now, the most common for building is, of course, the this one, this shallow foundation, which is um, s- um, spread footing or isolated footing. So basically, when you design this one, so if you have the load, of course, so this is your pilaster or pedestal, this or column. This is your footing. So you have to go. You have to design the area based on bearing capacity, right? And then if this is subjected to moment, then you have the P over A plus M over S plus minus. So it depends the direction of the bending or the moment. And then this will the P over A plus M over S will give you the maximum bearing pressure, and then the minus M over S would give you the, for example, if this is the direction of the foot, the moment go this way and in this direction also. So this will be the most stressed corner, and this will be the minimum. Um, then for um, isolated foot or the continuous footing, so of course you will have that's continuous. You only have to do is design a like in Imperial, the 1 foot strip, or in if it's in SI, then 1 meter strip. And then all you have to do is if this is your footing, so just design the reinforcement, the thickness based on like in one direction only. Like so it will you still design the direct shear, punching shear at the same time the bending, but in this direction only. So your main bars would be in this direction. This is your main bars. Then this continuous bar would be more like um, temperature bars. So before, like, was it 2 weeks ago? I posted a post in Facebook asking like, is it possible to have a foundation without reinforcement? I think I will just discuss that in a separate because we have a to me it was interesting. My like first time seeing that argument. So I will discuss that separately. But on this one, we'll just, you know, uh, focus on the types of foundation for any structure like building or um, towers or whatever it is. So this one, I think no question with this one. This is really common. The spread, this spread footing or isolated, and then the strip or continuous, or sometimes it's called the wall footing. So wall footing. So the next type would be. Oh, by the way, this is like just one of our projects. So this is the spread footing, and then this one. There's also spread footing. This is a basement, so there is no pilaster on this footing here. It's just directly like the column direct on top of the um, footing. But this one, this is a like an entrance. There's a canopy. This pilaster supports the canopy above. So and then it is of course the same depth as the basement footing. That's why um we have that column, this one, or pilaster. And then if we cut cross section here, this is the cross section. So you have the ICF. This is the um, ICF or insulated concrete form. So this is common in cold region where instead of using a formwork like the conventional formworks like plywood or whatever, they will use ICF. So that form will serve as well as an insulation. So this is really good for um, cold region. And then the way it is designed is the same as if it's just like a concrete. So um, it depends. Like there's the ICF. There's a 6-inch core, 6 inch. There's 8 inch. Then there's 10 inch. Then 12 inches. So it depends. Whatever you need. So on this particular project, we use the 8-inch core ICF system. So it will be designed like any regular basement wall, but just the only difference is that the utilizing this ICF like insulated concrete form. Now, next common building foundation would be this one. So this is a cast in place. uh, This is a cast in place concrete pile. Now there are two types for CSP. One is the straight shaft. One is the straight shaft, and the other is the underrim or build build pile. Now, in some I've seen only in textbook, but I've never seen it in actual. I never designed it in actual. Where instead of just single bell pile or single bell at the very bottom, it will have like another, another bell. If you I've seen this in one of the textbooks that I read, the foundation design book, but I never actually use this one in any of my projects. So I don't know. I mean, I have no experience, so I don't even know if I mean it's doable. The theory is the same in designing pile, but I've never designed something like that. So it will be so this is the usual pile. So you have instead of just single bell, it will be a series. It could be two or three uh, bell. So it depends. But like I said, I've never designed this like a pile like this before. But actually, when you design this one, this is exactly the same as if you design helical pile. But we will discuss that in later. So that's build pile or under rim pile and the rim foundation. So like I said, it could be just one bell or two or three. It depends. But in my experience, I only designed like just a single, like a very bottom, and then it will be designed as a bearing. So it will be in bearing. So if you remember in school, we were taught to, like when we design pile, you will have to, so you have the total capacity is equal to the skin friction plus the in bearing. But this practice has been um, deemed or not accurate anymore. Like in recent foundation, if you read recent foundation books, even in practice right now, like I've known like a lot of geotechnical engineers, and they will never recommend a combination of both skin friction and in bearing. They have an explanation. I cannot. It has something to do with mobilization. but I cannot explain it properly the way they explain it. So if you know any geotechnical engineers, you can ask this question: why it is no longer recommended to add skin friction and bearing for to get the pile capacity? But that has been the practice since I mean since I arrived here. That's what everybody is doing. Back then, when I was still working in an outsourcing company, I came across a civil report which says you can add this one, but lately I've never seen any um, recommendation to add those two. So it's either you design it for skin flexion or design it for in bearing. So that's a cast in place pile. Now in other this one I only came across this one when I arrived here in 2010. And then at first, like I was told by my supervisor, like, okay, the client wanted a screw pile foundation. I have never seen. I have no clue what it was. So, good thing he has a book. I posted that book in my page, the helical pile by Perko. So we have that book in the office. So I read about it. And then some, literature in the internet, and then my boss sent me to, I would say, at least two separate courses about this one, because this is I would say um, not not new, but only recently that engineers started using this again. And even the Deep Foundation Institute, DFI, they already I think uh, 2015 or 16, the issued a um, foundation design guide, like manual for designing this type of foundation. I think, if I'm not mistaken, I think they are in second edition already. I think, can't remember, but we have the first edition. Well, it was only like 2015, 16, I think. So it's recent, but this types of foundation has been like, I mean, the recorded based on like when I attended seminars, they said like it's been around since 1800s. So I don't know, but that was the um, what was said by uh, our lecturer. But anyway, so yeah, design of this one is design like um, so they are the advantage of this one, because through experience there is an empirical equation that you can use to determine the capacity of this pile based on the installation torque, and that is the torque correlation factor. Torque correlation factor, and then you can estimate the capacity of the pile based on the torque plug. So once the pile installer is done with all the installation, they will. I mean, if you specify this one, you will have a table, and then for each type of pile, for its geometry, you will assign a minimum torque. No, minimum torque. Um, So the pile contractor has to at least attain this minimum torque. Now, if they're like at estimated depth, if either you meet this one or not, you have to inform the engineer of record and say, okay, this is the torque log. Then the engineer of record will review the installation torque, and then I mean it's up to whatever. Like if it says okay, this is not enough, then go deeper. And then it's easy, just basically splice this one. So you could go like 60 feet down or 40 feet. So it really depends. So it can be used as a standalone or single pile, or you can use it as a single pile in battered. So because you still have to meet the minimum requirements, the same as any cast in place, for example, cast in place pile, where you have to um, space the pile at least three times the diameter. Then this one is also three times this is called helix. or helical plates. So the same. If in cast in place pile you space your pile three times the shaft diameter, this one is three times the helix diameter. And then if I mean there will be like it depends like the it's either you will use the cylindrical shear on this one for the capacity or the individual bearing plate. So if you are interested on this one, then you can have or you can buy that book by Perco or just search in the internet any literature about screw pile. So there has been new development on this. Like I I I reviewed a chef drawing. I think uh, late November. I think so. Oh no, yeah, November December last year. So I reviewed the chef drawing and then I noticed like why is this the minimum torque is really small compared to what I specified in the drawing. And then the so I sent that comment and then the engineer like the pile engineer says like um that's I mean that's what's based on the Canadian Foundation engineering manual. And then like I realized like why it's different from what I have. I'm also using the Canadian Foundation engineering. And then I didn't realize this in the new code in the latest foundation manual they changed this value. So that's why like the geometry is almost the same. I mean, that's the thing with like if you design this one, it really depends on how you interpret this whole report, how you do the geometry. You could be this one, for example, in design, you could have this just double helix, yeah, two helical plates, then large, say 236, or you can have 320. It really depends. So you have the freedom to choose like whatever you want. So the only thing with piling contractor is sometimes they have piles in their inventory, and then instead of using the one that I designed in the drawing, they will offer an alternative, and then they will use whatever they have in their inventory, and then just provide the stamp drawing with all the capacities, and with that is fine. Now, so so again, so I didn't realize that in the latest code or latest design manual, the correlation factor changed. Because this like right now, there are like PhD students that are still researching about this one. Then every time they will present it. Um, if it is, if it requires changes in the building code, then they have to, or the foundation manual, then they have to change it. So it's an ongoing process. So that's why when I learned that in the new code or the new manual it changed, so I have to update my calculation as well to reflect the latest correlation factor. So the advantage of using this one, that's why this is very common in remote areas. Imagine like you are, you know, like hundreds of kilometers away from highway and then away from big cities, and it would be almost impossible to bring in a concrete to do a concrete pile. But this one, all you have to do is bring in like excavator, then attach the pile. I already posted um I think many times about this in my page regarding like screw pile and then the different pile driver. All you have to do is just attach it to any equipment they have. Like it could be like bobcat or excavator or whatever they have. They will just attach it and then install the pile. Now the good thing with this one is it could be used in temporary structure where you install the pile and then once you're done, you will just take it out. So the way you install it, that's the same way. They just torque in reverse direction, then it will pull out. You can take out the foundation. And then with regards to corrosion, all you have to do is either specify like a galvanized pile or you consider the reduction in cross section for the corrosion. It depends on like how many years you intend to use this, like, or the lifespan of the building. Then whatever is the, how many micromillimeter per year, like for corrosion. It depends on how corrosive the environment is. If you are in marine environment, then that's, I don't think it's, um, I mean, you can still use it, but I think it's not recommended to use in a marine environment because, I mean, you can. I mean, no one would prevent you from using it, but you really have to account for the corrosion, and then it can be installed like at any angle. Like, you know, this one, I think this is battered. So the plan view of this is the um this is a foundation for a tower, transmission tower. So this is the leg of one of the tower, and then or one of the legs of the tower, and then the pile would be right here, and then this is battered in that direction. So that's why you are seeing this one here, and then at the battered, usually sometimes 10 degrees or 15 degrees, but um, you can install that up to, usually in my experience, we battered that one at most 45 degrees. So yeah, so that's screw pile or helical pile. And then yeah, so if you're interested in this one, get the book from by Perco, or you can the one of the biggest pile contractor here is Almita. So you can also download information from Almita. They have lots of research, like PhD students is sponsored by Almita. So you can read a lot of information on that one in the internet today. Now the next type of foundation, so this one is helical, is called helical or screw pile. Now the next type of foundation is driven pile. So I mean that's very obvious. So um, the most common back home for driven pile, this is why on earth it's no hard. So back home, the most common driven pile is concrete. So this is the most common. But here so far, I've been here since 2010. I've never seen a concrete driven pile here, only steel. And now this is what called grillage foundation. So this foundation. This is for a radio tower. So this is for a radio towers with, three legs. So the tower has three legs, so it's supported on this one, and then there will be like a cross beam. This one, then supported by three piles. So instead of the usual, for example, back home, if this is the for tower foundation, the most common is you have footing and pilaster on like three sides also. But here, because of like sometimes it's really remote and it's almost impossible to bring in concrete. They will just use a pile or driven pile. So for this particular example, or for this particular project, the client wanted a driven pile. But I've designed something like this one using screw pile. But this one, for this particular project, the client wanted a driven pile. So this one, that's really common, driven pile. It could be now this one. Um, I've encountered this one only when I joined another company, and this project was for a transmission line in like for like when we design the foundation, we have, I don't know how many types. Like it depends on the thing. But for this one, this is for if your ground is rough and you need anchor, because this is like a guy for a transmission line. So if this is the lattice tower, like that, whatever is the shape of the lattice tower, and then this one is cord, right? Guy wire. Now, right here in the foundation for this anchor, we use this type of foundation if it is rock, if it is on rock, like real rock, you know. My scope on this one, because I don't know how to design the geotechnical aspect of this one. So in our team, we have, um, I don't know, like at least 6, 7 geotechnical engineers, and then three of us, um, a true structural, but the other engineer is more of like a geotechnical at the same time as structural. But there are two of us that are pure structural, and um, this one, my scope on this one is design the structural part aspect of this, like designing this DVDAG anchor, um, the casing, this one, but the designing of this one embedment into the rock, and the grout, and etc. That's done by other my colleague, geotechnical engineer. I have no idea how to design that one, but my scope was the structural aspect of it, like the base plate or the cup plate, and then the casing. This is a straight steel casing, and then the anchor. This one, the Vidag anchor. So this is called micropiles. I have a spreadsheet on this one, but just the structural aspect of it. So if you are interested in learning micropiles, then you can also search. Um, there is a there is a I bought a book actually from Federal Highway. Micropile design. Um, so this one here. So this book, I don't know if you can see this one. Yeah. So this book, Micropile Design and Construction Guidelines, this is from the Federal Highway Administration. So I bought this book in Amazon, um, because before working in that company, I've never heard of this. I mean, I have no idea. So for me to do my job, I have to read about it. So book I bought a book about micropile, and yeah, so I designed the structural part of this. So that's called micropiles, and this is for Anchor. So I don't know if there's a like an application on this for compression, but um, this is I mean you could probably use this in a compression application, but so far I read about this one. It's only for tension, and basically if you need like this embedded into the rack. And then this is common for pumps in oil and gas. I've designed also a foundation like this one for a residential building. So the critical on this one really is, well, the same. You design the now there is a this is the cribbing, and then there's a timber mat. This one, so like a three layers of pressure treated timber mats serve as like a footing. And then this one, you still the check is the critical is overturning and sliding. So for the sliding, all you have to do is get the um, frictional resistance wood to wood, and then wood to ground. So whichever governs, that's your um, That's your frictional resistance. So whatever is the total weight from the formula, F is equal to mu times N, where N is the normal force equal to the weight of the building. So the heavier the building, the bigger the frictional force. Then whichever governs in the um, frictional coefficient is either wood to soil or wood to wood. And then you have to make sure that, because if it's wood and wet, that's different versus wood that is dry. So that's why you have to make sure that if you assume that this will be like in a dry condition, then you have to make sure that it is dry. So, and then the overturning, if the overturning due to wind and seismic is larger than the resisting moment, like the weight of the building, we will use it's called a duckbill anchor. So it's a duckbill anchor. Let me check if I can search it in the internet. Duckbill anchor. So this is what's called a duckbill anchor. It's basically just, pound this into the ground, and then it will open when you pull this up. It will open this one here. So you will have some kind of a rod. You insert this right here, and then you pound it down into the ground. And then when you pull that one, this will open, or it will be in this position, like perpendicular to the cable. Then it will resist the overturning. And then each type has a capacity. Uh, this one, that build earth anchors, and it's that build capacity. I think the largest one can resist up to 3,800 pounds, if I remember correctly. But yeah, if you're interested, you can search on that one. So we will tie the building. So if this is the building, uh, so if this is the building and then it's elevated, because you have a um like a skid, and then you will have your timber grading here, and then you will have your timber mat, and then all you have to do is basically, you know, anchor this one to the ground. If you cannot have that on this side, you can have this side. You know, just alternate so it won't overlap their stress, like the ground stress. When you pull that one, it will be like the same. Like if this is the ground and then you insert the duckbill anchor, then the projection like a cone. So that's the diagram for the shear plane of the anchor. It will be like a conical shape, and this you rely on the shear strength of this ground here. So its type of duckbill anchor has a capacity. I think like I said, the biggest one is 3,800, 3,500 pounds. I can't remember exactly, but that's what it is. So that's the um, timber craving. So so this one is for like a camp, workers camp in a on a oil and gas company. So, and then that camp, most of the time it will only, if it's like during exploration, then you're talking about like 1 or 2 years. But if it's for production already, then this camp would probably last like 20 years, 30 years. I don't know. It depends. So I've designed this one like this a lot, and probably more than 15 years and still there. I mean, some of the comps are still there. So I don't know how. But sometimes they will ask us to check the unit because this is relocatable unit, and then they will bring this to another site. And then last, when was that? 2 years ago. So I did this, I think 2 years ago. But the unit was from other location that I did in 2012. So that's what, 12 years? So 12 years. Um, then they move the unit and then we check the, you know, because all you have to do really is if this is, I mean, if this unit, because this is relocatable, all you have to do is check the snow load and wind load, seismic load in wherever the final location. So if you move this to another location, then you have to make sure that the snow load or the building is still okay for snow load, wind load, and seismic load, and then you design the new cribbing. So that's timber cribbing and timber matting. Now this one, I've seen this, um, not my project, but one of the projects where I think I sized a beam, I think, um, if I remember correctly. It was a long time. And I remember like it's called GU pier or RAM aggregates. All you have to do is drill a hole and then, put some gravel and then every layer just pound it like really heavy, like it's more like just compact it, like drop a heavy, it's like a drop hammer and then it will compact and then that's why you will see this like a some kind of like a layer by layer because that's first is you will pour a you will put a say 300 millimeter and then pound that one like with heavy object, then it will compress, then add another layer, then add another layer, so you will have like a solid um foundation. But this is actually like just gravel, it's not concrete, it's gravel. It's called a GU pier or ramp aggregates. I've never encountered or I've never designed something like this before, but I've seen one. Um, my scope was just design a beam for a house. It's a lightly loaded structure. It's a residential building, and then they have these from types of foundation. It was really interesting, but I've never designed something like this before. So I think that's it. But there's one bonus types of foundation. So I don't know what you will call this one, but it is. I mean, it looks crazy, but I mean, hey, it works. So this one, because so I had a discussion with other engineers on my page, and he's an engineer in Quebec. So we will discuss this like because we were both interested in this one, how to analyze this one. So I told him like I think when you design this one, it's more like the stiffness of the tire because it depends if this is summer tire or winter tire, so stiffness is different. And now if this is your tire, right, and then you put gravel in here, and then you pound that one, compress that one, then it will be confined by the tire wall. Now, if this is properly compacted, like the ground here, the gravel is inside or soil inside is properly compacted, and then it is confined by this the tire wall. And then, like I said, it depends if this is summer tire or winter tire, the stiffness will be different. So, to me, if you do something like this one, as long as it meets the sliding and overturning criteria, because that's what's critical. If this one is not located in a seismic region or a hurricane-prone region, then that should work. And then you just design the slab based on the stiffness of the foundation, then you are talking about a subgrade. That's your modulus of subgrade reaction, right? So the same way you design this lab will be designed as a grade supported with subgrade reaction. Then I don't know how to quantify the subgrade reaction based on this stiffness of the tire, but hey, it works. So anyway, so yeah, so other than like this one here, this these types of foundation I've been designing this like for you know considerable years already. So um, it depends. So if the clients wanted a screw pile, then I will design screw pile. If he wants driven pile, then driven pile. If it's timber craving, I will design timber craving. But and this one, like I said, only my scope on this one was for the structural part of it, and I have no idea how to calculate for the like this one here, the embedment length, and then the because this will be this hatch area, like outside the this portion here, like this one. This is a concrete grout because the casing is only up to here, and that's the casing. That one up to the top of the ground, and then it will be pressure injected grout here inside, and then it will enter all the voids in the concrete or the rock below here, and that would be the resistance for the. I mean, geotechnical engineers know how to do that one. But my scope, like I said, was on the structural part of the, I mean, structural only. So I designed the casing, this casing of this David Anchor. So in a way, so yeah, these are the types of foundation. And then this one, screw pile, I've seen this most of the time. This is for remote area like transmission lines, but I've designed lots of screw pile for commercial buildings, residential buildings, apartments. So this is not only for transmission lines, but this also used in building foundation. So yeah, so if you have any questions, just you know write it in the comment section, and I will respond to that when I have the time. Okay, till next time. Bye bye.